We are back with our latest version, upgraded version of what was the DRV 245 BD version 3. Oh, it was version 2. Now we have a version 3. We kind of rebranded under Speedy Squirrel, going with the peanut and squirrel theme here. So this is the Speedy Squirrel controller. This is the final version of the hardware, at least, that we expect to have for a while. We don't have any more planned updates. So far, testing's gone really well. We have tested with a variety of motors on the bench at every voltage from 10 volts up to 40 volts. Tonight, we're going to put this into the frozen Jeep. I have 4 brand new rigid 4 amp hour 18 volt batteries. Probably only need 2, so what I'm going to put 4 just to make sure they don't blow fuses. So I'm going to leave 30 amp fuses in the wiring. It's pretty thin, 14 gauge wire on the adapters. 4 amp hour lithium ion battery really should not exceed about 20 amps continuously. 30 amps is going to be fine. 5 to 10 C is the recommended maximum of high quality lithium ion cells. So you can assume 4 amp hour times 5 to 10. So that's somewhere between 20 to 40 amps is the maximum continuous current. On the 14 gauge wire, 30 amps is going to be really the limit there. So we're going to leave 30 amp fuses in. I'm going to run 2 of these in parallel. So what I have here is the rigid adapters from Amazon, and you can they nicely marked plus and minus for you. They match the red and black wire. So to do series, to double the voltage, you have on one of them, you're going to run the black to the red. As you can see here, I have black coming into red, into black, and then red from the other one. So let's check that. Let's plug this in and check that voltage. Let's put some of this stuff aside. So voltmeter, these Klein voltmeters, they default to AC. Always remember to switch to DC if you're using a Klein meter. That, for the most part, the Klein is targeting AC household use, homeowners and electricians, not engineering, which usually defaults to DC. So let's see if we can see this on camera. I don't think we can read that. Let me zoom in on it. I think we can see that pretty well. So these are fully charged, just came off the charger. First, what I'm going to do is I'm going to go across both batteries. Let's check that voltage. And what I'm expecting to see is about 41.5. All right, we have 39.4. After they sit a little bit after being on the charger, they do decrease a little bit. So 39.4 is normal, fully charged. Absolute maximum out of 2 is going to be 42 volts. So keep that in mind as we talk about this speed controller and as we put it in this Jeep. We're going to go across both batteries and we're going to get roughly 39.5 volts. Fully charged, 2 packs in series can be up to 42 volts. A single standard 18 volt drill battery is 5S lithium ion. And I do believe DeWalt is making some lithium polymer. They don't really advertise it's lithium polymer. I think they're advertising it as a power pack, but I believe they're lithium polymer cells in there. So single batteries, 5 series lithium ion cells. So 2 packs in series is going to give you 10 series lithium ion cells. Now, recommended when you're doing this, have the exact same pack, have them both charged up, because the low voltage protection on the board is across both packs. It's not across a pack individually. Most of the packs have BMSs inside. It sounds like Milwaukee does not. So Milwaukee doesn't have the internal protection. As far as I know, every other brand does. I'm sure there's some other brands that don't if Milwaukee doesn't, but keep that in mind, especially if you're using Milwaukee. Use the same packs and set your low voltage threshold accordingly. All right, so now let's check a single pack. So 2 packs you saw was roughly 40 volts, single pack roughly 20 volts. So if you can see the wiring here, let's try and make that visible. So, positive to negative, positive here, negative here, and there we go. So what I am going to do when I install this in the car is this extra terminal on these Wago connectors. That's going to be a second set of series packs. So I'm going to have 2 packs in series times 2. So 4 packs total to get plenty of current. Motors we're using are their Johnson 18 volt motors. These spin about 23,000 RPMs at 18 volts. They have a really cool brush design that I don't know if it's more reliable or not, but it sounds cool and it runs really smooth. We've been running these in the Jeep for a while. I'm not actually replacing the motors. These are just the same motors we run in the Jeep. We have these adapters that we designed. We're going to start selling. We did a bulk order of these motors, and we're going to start selling these adapters with them. So this is an 887 to 775 adapter. So this collar and these screw spacings match a 775. So, and just for reference, here's a 550, 775, 887. So you get a bit bigger, bit bigger can, bit bigger wire gauge. It is roughly double the torque at the same RPM as a Vex Pro or Andy Mark Redline. I'm gonna get this installed quick, and then tomorrow when the kids wake up, they can test drive it. Maybe I'll try and drive it in the garage. Here is the frozen Jeep. Currently what I have in here is the DRV 245 BD version 2 that we originally had designed for 42 volts as the maximum voltage, and then there was an issue with the MOSFETs we had selected, and that is what resulted in going back to the original MOSFETs because we knew those worked at 42 volts. Unfortunately, they are only rated, so this is the new controller. It's exact same PCB, no change to the PCB. The only change was the bill of materials. We swapped out the 100 volt MOSFETs back to the original, which are 40 volt MOSFETs. So the peak, or the rated voltage on those MOSFETs is maximum 45 volts, typical 40 is the maximum. So each one is supposed to be tested by the manufacturer to 40 volts. Yeah, we're pushing the limit there. If we're having a reliability issue with exceeding that 40 volt limit of people putting 2 drill batteries in series and running 41 and a half volts, then we're going to reprogram the controller to limit the voltage to 40 volts and kind of unfortunately block out that 10S number. Get started. Let me show you how to install this. We're swapping from one to another, so it's going to be real easy. I've unscrewed it. Now, this is the high power section. This is low power. So this is logic with the exception of the 12 volt output and the on control, the V in plus to on. This is high power. So don't connect any kind of high power to this side. You will likely damage it. Connect high power only to this side. So we have the motor A, motor B, motor A, and power input. Please pay attention to plus and minus. These two negatives are the same. You can connect to whichever one you want or both. Same with the positives. Connect to whichever one you want or both. If you're going over this install, I should be running a second battery wire from the battery in the front compartment to the back, but I'm probably not going to run a second wire tonight. So these go to the motors. Motor A, motor B. These motors have wire leads coming off of them. They're pretty small gauge, but they're extremely short. I haven't had any issues with these overheating. We've been running these for, I think, 6 months now. I have had maybe one set burn through a set of brushes. I don't think it was one set. I think I've only had one motor burn through brushes. These brushes last quite a long time because of the design. There's a spring that, there's a brush that's pretty long. and the spring pushes it down. So it just kind of slowly wears down on the brush. Logic side, I have a pedal, and then this one, I'm using the 4 original motor wires from the gear selector to determine direction. And then these 2 wires are plugged into +12 to battery negative, and that is for powering basically the gear selector. There's no other accessories on the Jeep. And then there's the jumper wire. I don't spend the time to install switches. This board has flat blades for these terminals. So there's 2 versions of this terminal block, and depending on what I can get, they're either going to be flatheads or Phillip heads. This batch right now that we're going to be offering for sale, hopefully next week, in a couple days, depending on when this video gets posted, are flatheads. Yes, flatheads. So that will be switching back and forth between flatheads and Phillip heads, because these go in and out of stock. One's available sometimes, the other's not. I have connected the 4 motor wires for direction selection, and then the positives. Just need to do the throttle pedal. Green goes to the T for throttle, red to 3.3 volts, and black to be negative. There are 3 dedicated terminals just for those. These are some small thin wires that are a pain. Now, you don't have to, when you buy these pedals, I don't do the connectors just because I buy these bulk and the connectors seem to change. I don't know, you don't always get the exact same connector, so I don't bother putting a connector on the board, because then I don't have to deal with it changing. And then you can use whichever pedal you want as long as it goes from 0 to 3.3 volts. You can just pull the pins out of the connector, and usually those fit in here, and that's much easier to deal with than stripping these very tiny gauge wires and trying to put them in the terminal block. I did not pay attention when I disconnected the motors. I didn't pay attention to the polarities and where they were going. So we'll go ahead and guess. What I usually do is I do all of the black and reds in the same orientation, and that just gives me a baseline to start from for getting the directions right. Before I do this, I want to show you these terminal blocks. So if you can see the top part here, the wire goes in the top, not underneath. So as you screw, this comes up and squeezes the wire. You want to squeeze it up. So you do normal directions on the screw for tighten and loosen. So clockwise to tighten, counterclockwise to loosen. So when you're tightening the wire in, clockwise. These connectors are up to 6 gauge and are up to 65 amps continuous current. Probably not quite continuously, because that's going to be too much power for them. They are claimed 1100 watt motors. I think realistically they're about 500 watts each. They also have really good efficiency numbers. Optimal efficiency is 81%. That's brushless motor territory. Getting close to it. And they do seem, at the lower voltages, 18 to 24 volt. This Jeep was running dual 12 volt lithium iron phosphate batteries, so about 26, 27, 28 volts. And it did seem to be pretty close to that peak efficiency number. Okay, we are all wired up. We're ready to plug it in. Got the batteries. We're just going to put 2 in right now. Plug it in. And we're going to set everything up, make sure everything's working. So, 1 LED on the board that's visible. That is the enable. That indicates the board is up and running, good to go. If that LED does go out and you can still connect to the Wi-Fi app, that indicates that you are over the peak voltage, which is 43 volts. Means your input voltage is higher than 43, that light will turn off. I don't believe there's any other reason that light would be off other than a failure. Let's get our direction dialed in. So let's check. Right now we're on forward high, and then I need to go grab a phone and log into the app to change the network name. Let's see, so forward high, that motor is reverse, this motor is forward. Let's check reverse. That one's going forward, that one's going reverse. Let's unplug it. Swap this motor polarity. I'm going to do it at the Wago connectors. Both motors are reversed. Both motors are forward. All right, let's screw it in place first. We supply 4 just basic screws with each motor controller, so you can screw it in place. Grab my tablet, a little bigger, easier to see on camera. Plug it in. Once you plug it in, that red LED is going to come on. You should see speed control show up in your available Wi-Fi networks. Click it, and you're going to navigate to your web browser. And if you don't get a notification box showing up fast enough asking you to connect, just type 4.3.2.1. Oh, you have to put the password in. Password speed control. That's on the cover. That hasn't changed from any of the other versions. Capital S, capital C, speed control, no space. Log into the browser, 4.3.2.1. And you should see the home page. This is software version Speedy 3.0.0. I expect that to be the version that starts to ship. That's why we're testing, just in case. And here you can change the network name, set your high limit, low limit, reverse limit, ramp up, ramp down. It's a 1/4 second ramp up, 0.2 second ramp down. So that's the time it takes the throttle to go from 100% to 0%, 0.2 seconds. Keep that in mind. It is going to add, 0.2 of a second is pretty negligible, but when you do increase that number just a little bit, it really does start adding to the amount of time it takes the car to start slowing down and braking. Coast time, I set that for 1/2 second. I have had issues where transitioning from full throttle to brake too quickly causes the fuse to blow connected to the batteries as it's forcing that current into the battery that was going through the motor. Brake ramp up. That's the amount of time it takes to go from 0 to 100% brake. And remember, this is auto braking. As soon as you let off the gas, throttle, and it ramps down to 0%, it's going to start, after that 0.5 second coast timer, it is going to start ramping up brakes. You can decrease that. I don't have there's not a major reason for it to be 0.5 other than to smooth things out. I think I hard coded 0.1 seconds into it, so you can't do anything better than that. So I don't think there's any concern anymore about putting that to 0 and blowing fuses. You can restore to defaults, and anytime you make a change, you have to hit submit settings. And then this is the software version, Speedy 3.0.0. So this is version 3 hardware, and then version 0 is the software, and then 0 is the web page. So remember, change the name of the speed controller to Speedy to make it an easy to remember name. Throttle pedal comes enabled by default. So if you're not using a throttle pedal and you want it to go based on receiving direction, you're gonna have to disable that throttle pedal. A cool thing about this feature, one second. Let's say you have new motors that you want to brake in. What you can do, you can go to the home page. You can set your limit pretty low. And then you can go to your setup. You can turn throttle off. Let's just check which direction we're in, forward high. Submit. So you can set a pretty low limit and brake in your motors. It's a pretty cool feature that I use all the time. Well, every time I'm braking in a motor. Brake pedal, if you're going to use a brake pedal, you do have to enable it. That won't register. You don't register any brake position without enabling that. There are some adjustments here. Low voltage cutoff timer and low voltage cutoff threshold. Make sure you set that for what you want it to be. I am going to set that to 33.5 volts right now. So that'll be, per cell, that would be 16.75 volts. So that's about where they're per battery pack. If it's split evenly, and I gave it some bit of buffer. No idea if these rigid batteries have low voltage protection built in or not. Overcurrent limit, default comes to 45 amps per motor. Time to exceed, that's 2 amps. Set that to what you need. Detect motor stall, so that's if you're limiting current and it drops below 50% of your set maximum. So if you're going below 50%, then you're gonna start that detect motor stall loop in the code, and then it'll stop the motors, hopefully from burning up. Diagnostics, this hasn't changed from previous versions. You have motor A current, motor B current. This version of the board, so the new look from the 230 to the 245 and now Speedy, that current is accurate to about an amp. From 0 to, I believe, 53 amps it maxes out. So that is a reliable value now. It's a real current detecting circuit, not something that I kind of added to the board with just discrete components. And you have max power, saves that. That's that peak current that's calculated, so there's a little bit of filtering on it, but not a lot. So really, if you're trying to figure out what your current and power is, open up the app and watch it. Fault condition, that's based off the gate driver. If you have a fault there, you probably have a failure, and the board's probably not going to function anymore. Throttle and brake position, your active direction, you can change that. That changes real time. Your input voltage, 41.3 volts, over the 40 volt maximum. So we'll see how it goes. Total runtime, so that's the amount of time with the pedal pushed down. So that's technically higher than 3% throttle. It starts counting for that timer, and that's saved. That does get reset when you reset the board. So if you don't want to lose your hour counter, don't reset the board. All right. For now, that's everything. Oh, let me change the network name. Network name doesn't take effect until you reset. So you have to remove power and re-enable power, and then you'll be able to log in. Another thing, every time you log into the page, make sure you refresh it. Just refresh the page, because if it was still open from the last time you logged in, and if you logged into a different car, it saves all that, and then if you hit submit, then you're going to submit all of the parameters for a previous car. So make sure you refresh the page if you have multiple cars. All right, that concludes the installation. We're good here. We'll be back with a kid to give it a test drive. Is it good?
Yeah.
That's better? Alright, it's set to 50% only.
Oh.
Should we turn it up?
Yeah.
Is that good? Should we leave it like that? Yeah, we'll see how long those motors last.
Mm-hmm.